Number 26 and number 27 were all about polynomials. This is a polynomial function. And to look for the solutions, you can put this into the calculator. I believe they gave you the picture in the actual question, and see where it crosses the x-axis. So it crosses at 4 places, and there's your 4 right there. -4, -1, 0, and 2. So those are the roots or zeros of that polynomial, 4th degree equation. For 27 part A, this was not an equation, this is an expression. So in an expression, they ask you to either factor completely or factor. And the first method of factoring I always look for is GCF. And they do have a common x. So I factor it or divide it out. But I keep it throughout the whole problem. You can't just throw it away. This is an equation, right? This is actually, this expression and the factored expression will be equivalent in the end. So this is going to be your tricky trinomial because the coefficient of x squared, the a if you will, is not equal to 1. So what do? We say do 3 times -35, I get -105. -105 that add up to 16. Now here's a little trick if you want to find the factors. If you go into y1 and you put that constant, which is -105, divided by x, and then you look at your table, it's going to give you all of the factors of -105, which is fantastic for something that's really difficult to find factors of. I myself did this for this question. And then you look at the 2 columns and see which ones add up to 16, and this did. So now what I do is I'm going to rewrite that 16x as 21x minus 5x. Now, the reason why I did that is I want to use grouping. And I couldn't use grouping with 3 terms, but I can use grouping with 4 terms. So now I can group these 2 together, and I can group these 2 together. So I'm going to do a GCF here of 3x, and I'm left with x plus 7. I need an x plus 7 here, so I'm going to factor out a -5. Now I'm going to factor out the x plus 7, not forgetting the x from the beginning, and what's left over when I divide out the x plus 7 is my 3x minus 5. Now you can check this. You can check this with mock substitution. You can plug in a 3, it will be equivalent. Just make sure if you're doing something like that as a part 1, make sure you check all 4 of your answers. Sometimes they give you an answer that's not completely simplified. Now for part B, this is an equation. You can see the difference between the 2. This is a polynomial or cubic equation. I'm going to use factoring to solve it, okay, but I'm actually going to get solutions to it. I'm not just going to factor it. See the difference between the equal sign? A lot of you ask me that question. First method of factoring is GCF. I can factor out a 3x. Now I'm lucky I'm not left with a tricky trinomial situation, so it's just AM trinomial. Factors of -6 that add to -1. Don't drop that equals 0. You're going to set each factor equal to 0. This you're going to divide by 3 to get 0. This you're going to add 3 to get 3. Subtract 2 to get -2, and these are my 3 solutions. You could check this by putting this into the calculator in y1 and graphing it, and this graph will cross the x-axis at 3 distinct places: -2, 0, and 3.